Okay, we have here today another integral from the MIT Integration Bee from 1991. This was problem 28. We have the integral of e to the 1 over x times x to the minus 3 dx. Okay, so the first thing I want to deal with here is just this exponent on e right here, because I think this would be much easier to deal with if we just had e to the x, let's say, then we know how to integrate that. So what I'm going to do is we'll do a u substitution for this and see what happens. So I'm going to call my u equal to just 1 over x. In order to simplify that, we'll take a derivative. So our du value is going to be, derivative of this is going to be minus 1 over x squared dx. And then before I substitute, what I'm going to do is we're going to rewrite this. For x to the minus 3, now this is the same thing as 1 over x cubed. So what I'm thinking is we can actually create a 1 over x squared just to set up this u substitution. So let's write it out that way. So I'm going to have e to the 1 over x. Then we'll split up this 1 over x cubed. I can create this minus 1 over x squared, like this. But then, so that I'm not changing it, we'll multiply it by minus 1 over x. Just noticing if you multiply these two together, you get back 1 over x cubed. And then we'll have our dx on the end. But then doing that, this whole piece over here, that's just our du that we have over here. So we'll go ahead with this substitution. So now this is just going to become e to the u. So we have e to the u. This is a minus u, but I'm going to bring the minus out front of the integral. And this whole thing here is du. But now this is actually just some pretty standard integration by parts. So we'll do this really quick with the di method. Tabular integration over here to the right. So I'm going to differentiate u, and then we'll integrate e to the u. Then we'll just differentiate here on the left. So derivative of u is just 1. Differentiating again, derivative of 1 is 0. Integrating e to the u, we get e to the u. Doing it again, we get another e to the u. So our solution is going to be here on the diagonals. The last row we've got is 0, so the integral of 0 is just nothing. So we can just take our solution on the diagonal. So we can factor out an e to the u and write this as u to the minus 1. But I don't want to forget this minus out front, so I'm just going to use this to reverse the signs. And then we just need to back substitute in order to finish this thing off. So for the final solution, we're going to have e 1 over x, and I can write this as 1 minus 1 over x plus c, and that's it. Okay, quick problem from MIT in 1991. Thanks everyone for watching. Have a good day.